Okay, ladies and gentlemen, we're back again. This is Dr. Robinson, and we're going to continue our studies classifying triangles, acute, obtuse, or right, given side lengths. So our vocabulary for classification: a right triangle is the sum of the legs squared is equal to the square of the hypotenuse. Then the triangle is going to be right. That is the Pythagorean Theorem, or Theorem of Pythagoras, where he stated c squared equals a squared plus b squared. A right triangle has only one angle that's exactly right. So right here we have our little box that indicates that this is a 90-degree angle. So it's exactly 90 degrees. Acute triangle is the sum of the length. If the sum of the lengths squared is greater than the square of the hypotenuse, then the triangle is acute. So the formula you should have is a squared plus b squared. Instead of equaling c squared like Pythagoras said, a squared plus b squared is going to be greater than c squared. And that will end up having acute triangle, because acute triangles are triangles that have all the angles less than 90 degrees. So if it were a 90 degrees angle, a 90 degree, all of the angles are less than 90 degrees is what we're aiming for. If it were a right triangle, so let me just go backwards for 1 second. If it were a right triangle like this one, I'm going to take it and let me show the vertices, and now watch how the angles are changed. So if it was acute, I'm going to take the side A and B and I'm going to lengthen them. And let me just show you also the length of the side so you can see. Let's see the side lengths. So this is 4.5 and this is 4.1, 5.8, and this is 4.1. Alright, so that's a right triangle. Two sides are equal to the square of the c squared side. So I'm going to take these sides, A and B, and they come together at this vertex right here. Notice I'm going to drag them and make them longer. So these are longer. And now notice what's happening as I drag it, drag it, drag it. See, remember this angle here was a 90-degree angle, but now it's less than 90, it's 50.5. And if you notice, the other is 57.5, and it is 72.2. So side C is no longer the hypotenuse. So you have a different type of triangle where all of the angles are less than 90 degrees, which makes it an acute triangle. So let's put it back. So there's your 90 degrees. So there's your Pythagorean theorem would make this a right triangle. So that's how you can prove if it is a acute. So if we drag that, because side A and side B are connected by this vertex right here, and if we drag it out, notice if it was to get acute as we drag it more and more, and they get longer than side C. When we square them, they'll be longer, and we'll see an example of that. Alright, let's take a look at the next definition. Obtuse triangle is the square of the hypotenuse. If the square of the hypotenuse is greater than the sum of the legs squared, then the triangle is opposite, obtuse. Sorry. So here we have side C, the hypotenuse is going to be greater than the legs squared. So when we have that, we have what's called a obtuse triangle. One of the angles is more than 90 degrees but less than 180 degrees. So let's go back again to our right triangle. And this time we're going to lengthen the sides of side C. Here is side C, the hypotenuse. We're going to make it even longer than it is. So watch what happens to these angles and the side lengths. So let's make them longer, and that's, now notice this is 6.7, and now let's drag this and make it longer and longer, pull it, we can turn it and twist it if we want to. But this is now 6, and that's 6.7. Side C is much longer than it was before. It's now 11.2. So if we square this side and square this side, we'll find out that C squared is much greater than that. And we're going to do an example to prove it. So let's go to our calculator and actually prove that right now. So give me 1 second to get my calculator. Okay, I got my calculator. So let's take a look at taking the side squared. So that would be 6 squared, side A, and side B is 6.7 squared plus 6.7 squared. And let's see what that equals to. 80.89. Now, let's take 11 squared. Well, I know 11 times 11 is 121, but 11.2 squared, and square it, is going to be even greater. That's 125.44. So let's go back. So in looking at that, let's go back to our definition of obtuse. When the hypotenuse is greater than the sum of the legs squared, and we squared those two sides, the hypotenuse was bigger, then you have an obtuse triangle. So that's how you prove it. So let's try an example or two, see if we can get it. So here's an example of a triangle. So what type of triangle we have here? Again, we start off with our Pythagorean theorem, c squared equals a squared plus b squared. So if this is 6, and this is 8, and this is 10, if we square each side, we'll have 6 squared plus 8 squared equals 10 squared. And that reminds me of the 6, 8, 10 triangle, so that is a right triangle. So we square all the sides, and then see if they're equal to be a right triangle. So that checks out to be a right triangle. Now this one, what kind of triangle do you think it is? Here you have 6.7 squared, 6.7 squared, and you have 9.5. So let's get our calculator in this. And let's use our Pythagorean theorem to see which is going to be greater. So 6.7 and square it plus 6.7 squared. What is that equal to? 89.78. Now we got 9.5. Let's square that. Oh, that gives you a little bit bigger. So the hypotenuse is a little bit bigger than the legs squared, just by a little, but every little bit helps. So that means since the hypotenuse is greater than the legs, we have an obtuse triangle, because c squared is greater than a squared plus b squared. So what I did was I squared my hypotenuse, squared my legs, found out what the value is, then added them up. Notice that they're not equal, so now I compare which one's greater. The hypotenuse is greater than the legs, so since my hypotenuse is greater than my legs, then I have an obtuse triangle. So here's one for you to try. See what type of triangle it is. And if you think you can do that one, here's another one. Try to find out what kind of triangle does the sides 9, 8, 9, 6, 8 make. So remember, if you remember your rules on Pythagorean theorem, C is the largest side, so 9 would be your C side in case you forgot. So use your Pythagorean theorem. Here's another one. What type of triangle does this make? And here's another one. Check your understanding. So I hope you're understanding what's going on with this video. This is where I'm going to stop and leave you alone, because hopefully you got something out of it. If you're having difficulty, write down your questions, bring them in tomorrow, and I'll be glad to answer them in class. So this is Dr. Robinson signing off. Bye-bye.